prepared by the reaction of cadmium chloride, with Grignard reagent, which gives ketone, So first of all, what we need to do, we need to prepare this dialkyl cadmium. And how we can prepare? We need to react cadmium chloride with Grignard reagent, as I'm going to react this with Grignard reagent, RMGX, as you can see, and then CdCl2, that is cadmium chloride. So as you know that this is your negative, this is your positive, again this is your positive, this is your negative. So negative will be attracted by positive, and it will be R2CD dialkyl cadmium plus this is your positive negative will combine together, which will form 2MgXCl. Are you getting my point? So we just prepared dialkyl cadmium, and after preparing this dialkyl cadmium, we are going to react this dialkyl cadmium with acyl chloride. This is your acyl chloride. So you need to take 2 moles of this in order to balance it only. This will have negative, this will have positive, this will have negative, this will have positive, and this will attack on this. So it will become R-C double bond O, and this R will come here. And you can see chlorine will negative will go to this, and it will become CdCl. Again, you are going to use this CdCl2 here, react with Grignard. Again, you will form this dialkyl cadmium, and this dialkyl cadmium will be reacting with acyl halide, forming ketone. Okay. Is that clear, Firaz?
Yes, sir.
Let me know when you're done with this.
Done, sir.
So this is the first method of preparation of ketone. Now the second method is from nitriles. Nitriles you already know, it's RCN, and it's varies from nitriles. CH3CH2, C triple bond N. This is your nitriles. And if you're going to react this with C6H5, MgBr, in the presence of ether, what will happen? So it's very easy. As you can see that this will have positive and this will have negative. Again, this will have negative, this will have positive, because nitrogen is more electronegative element and one of the bond will be broken. So what will happen here? It is CH3, CH2 as it is. Then there is a carbon, and the bond between carbon triple bond broken into double and becomes N. Now you can see this will go to the negative. So it will be MgBr, and this will go to the positive. So the benzene will come. Now what will happen? You are going to do the hydrolysis. So on hydrolysis, this part will be eliminated and oxygen will be added there. So here is what you will get. Then this way you will get the key. Which has a name, propiophenol. Propiophenol. This is a common name. If you want to write the what we say, the UPSC name. So you can see this is your benzene, which is connecting like this: C double bond O, then CH2, then CH3. So you can easily write the UPSC name: 1-phenyl propanol. 1-phenyl propanol. Is that clear, Firaz? Let me know when you're done with this.
Done, sir.
Very good. The next one is quite famous, and you have seen it in the last two chapters: haloalkanes and haloarenes. That is acylation. So the third and the last preparation of ketone is from benzene. Either you can do from it benzene, or basically substituted benzene. Substituted benzene. If any group is attached to benzene, that is substituted benzene. Now see what will happen if you are going to react this benzene either with air, that is arenes or benzene, which is attached with acyl chloride in the presence of anhydride AlCl3. So what will happen? This whole part will go, and one of the hydrogen will be substituted by this part. So you can see this is what you will get, either R or AR. And here you can easily understand that this is your ketonic. So basically, Friedel-Crafts acylation reaction generally gives you Friedel-Crafts acylation reaction that will give you ketone. Okay, so please do write it. We need to do only one chapter after this chapter, right? Amines.
Done, sir.
Very good. Now we are going to do the physical properties, which generally deals with the boiling point and all. So I'll write the topic physical properties, and I'm going to give an idea of this boiling point that we had already discussed in the previous chapter as well. Boiling point is generally directly proportional to molecular weight, because molecular weight is directly proportional to force of attraction. Okay, if you are having one kind of compound, then go for molecular weight, and if molecular weight is same, then boiling point is directly proportional to surface area, or you can say inversely proportional to branches. Are you getting my point? We already discussed in the previous chapter about the boiling point. Yes or no, Firaz?
Yeah.
Also, it is very important to note that if you have N-butane,
So what is the first line again?
this is the boiling point directly proportional to molecular weight, which is directly proportional to force of attraction.
Yeah. Okay.
So I'm going to give you some of the compounds name, which are almost comparable mass, which have comparable mass for propanol, and then acetone, and then here comes propane one-all or propane. So can you choose, can you arrange this in increasing or decreasing order of boiling? The alcohol will have the most boiling point because here hydrogen bonding will form the strong hydrogen bonding. After this, you will get to know the ketone
Ketone.
part, ketone. And after this, you can see
Aldehyde.
this is your aldehyde. So it will be aldehyde. And then comes your
Ethane.
methoxy. And then comes your
Butane.
butane. Okay. So we can write also in this, right? Is that clear?
Yeah.
Okay. If I'm going to give you a question on this, like, can I change the slide? Okay, just write it, and then I'm going to write CH3, CH2, CH2, CHO, which is butanol. Then comes your CH3, CH2, CH2, 1, 2, 3, 4, CH2, and then which butanol. Then comes your C2H5, oh, C2H5, which is ethoxyethane. Then comes your butane, CH3, CH2, CH2, CH. Arrange in increasing or decreasing order of boiling.
So increasing would be
Decreasing
D.
in
Increasing. D first,
D,
then C, then A and B.
right. Can you change the slide?
Yeah.
No. Now see.
These questions we have to give like reasoning, right? What will
Reasoning,
be the
yeah,
like reasoning?
or not reasoning. It will be like arrange the following compounds in increasing or decreasing order of their boiling point or acidic strength, like this. And it can be also asked like why alcohol or propanol is more, why propanol has more boiling point than propanol. Are you getting my point?
Yeah, because of hydrogen bonding.
Yeah, because of the strong hydrogen. So let's start this chemical reaction, and in this we are going to first study about nucleophile nucleophilic addition reaction. Nucleophilic addition reaction. From the name, you can get that there will be addition of nucleophile. So if you are going to add nucleophile, so the place where you are going to add must be electron deficient. Are you getting my point? Nucleophile, that means electron
Yeah.
rich, and nucleophile is attacking somewhere. That means it is electron deficient compound. So now you can see that this is your carbonyl compound. That here in this topic, we are going to deal this carbonyl. Consider this carbonyl as either aldehyde or ketone. This is in 3D basically. This is your B. So as you know that oxygen is more electronegative element and it is more second most electronegative element. So what it will do, it will take electron from carbon. And there will be a nucleophile which is waiting for this movement so that it can attack on the electrophilic center. That is going to be at carbon. Are you getting my point?
Yeah.
And you also know that this compound is planar because it has a hybridization of sp2, right? So this is your step 1 that I'm going to write, and it is slow. And always remember that the step which is slow is rate determining step. So what will happen here? Nucleophile will add here, and oxygen will be like this, and then A will be like this, and then B is here. Okay, which has tetrahedral intermediate. This is your intermediate. Intermediate is something that is in between reactant and product. We also sometimes called it adduct, tetrahedral intermediate. Intermediate. And now again in the second step, which is faster, in the second step, which is faster, you are going to react with H. This is your step. And you know that this positive will go to the negative. So what it will form? It will form like this. There is a nucleophile, there is OH, and then there is B, and then there is. Is that clear? And we call it addition product. Is that clear?
Yeah.
Please do that. Let me know when you are done with this.
Done, sir.
Very good. Now, if I'm going to ask you a very simple question regarding reactivity of nucleophilic addition reaction towards aldehyde and ketones, what will be your answer? Like, let's take an example of a general formula of this. This is your aldehyde, and this is your ketone. And if you are having a nucleophile and any side, can you tell me nucleophile can easily attack in which, or it will attack with the same rate in both aldehydes and ketones?
With the same rate.
No, not with the same. The reactivity of aldehyde.
R will be slower because of steric index.
Yeah, reactivity will be more in aldehyde due to steric hindrance, because on the right hand side only hydrogen is there, but here in an alkyl group minimum CH3 will be there. Okay.
Yeah.
Can I change the slide?
Yes.
Now we are going to discuss about some important examples of nucleophilic addition reacts, or sometimes it is like nucleophilic addition elimination reacts. Nucleophilic addition elimination reacts. So we are going to discuss about this. So the first one is basically your A part, addition of hydrogen cyanide. Hydrogen cyanide. First of all, you need to know this hydrogen cyanide is not a very good nucleophile in its pure form. So we will catalyze it in the form of Cn minus hydrogen cyanide. You know, it has a formula, this HCN, and in pure form it is not a very good nucleophile. So we will make it a very good or a strong nucleophile. So I'm going to show you the reaction first. Can I change the slide? Are you done with the topic?
Yeah.
Okay. So see what will happen first. You need to make it a strong nucleophile. In order to do this, I'm going to catalyze it with the base, and it will form basically Cn minus, which is being a strong nucleophile, and H2 will be eliminated. Now we are going to use this, and it's very easy. If you are going to react this with a carbonyl compound, you know what will happen. You already know what will happen. As you know, oxygen is more electronegative element, so it will attack here. It will take electrons from carbon, so electrophilic center is on carbon, so it will attack. Now see, there will be tetrahedral intermediate, CO negative, then here you can see Cn comes, and then this part, which is tetrahedral intermediate, right? As you have seen in this in mechanism earlier or above one. Are you getting my point? Enter.
Yes.
Mid. Now you can see that this will be going to react with the acid, and what it will form? It will form basically OH is there, and wherever you can write OH is there, Cn is here, and this is like this. And this is known as basically cyanohydrine. This is known as basically cyanohydrine. Since we have done the mechanism, it's very easy to understand. Only what you need to keep in mind is that this HCN is in pure form. The reaction will be slow. If it is in pure form, the reaction is very slow. Reaction is very slow. So that's why we catalyzed with base, and it forms Cn minus, which is a strong nucleophile, and it's very easy, right? Please do it. Let me know when you are done with this. Are you done with this?
Yes, sir.
Very. So this is the first example that we just deal with. Now the next example you can consider B is addition of sodium hydrogen sulfide, and it is very easy. Addition of sodium hydrogen sulfide. Now you can see how you are going to add. So it's simple, very simple. Aldehyde or ketone is here, and you are going to react it with NHSO3, which is sodium hydrogen sulfide. Now you also know that this will take electron from here. So this will have positive charge and this will have negative charge. HSO3 minus will have negative charge. So you know that this will be attacking on carbon. So what will form? What will be the formation? You can see C, and with SO3, HSO3, can I write this part as OSO2H? Both are same, SO3H or OSO2H. So I'm going to write it here, OSO2H. And here you can see Na plus will go with the negative one. So it will become ONA and the rest part is as it. Then proton transfer will take place. Proton transfer. Proton transfer. That means basically Na plus, what I want to say is that Na will take position of hydrogen and hydrogen will take position of Na. And this is how OSO2Na. This is OSO2Na and this is OH. And this is basically a solid compound which is crystalline in nature. And the compound is bisulfide addition, bisulfide addition compound. And it is this. Please do that. This section is quite easy. Let me know when you are done with this. Let me know when you are done with this.
That's it.
Very good. So this is the B part that we did addition of sodium hydrogen sulfide. The C part that we have already done in the previous chapter, addition of Grignard. Addition of Grignard. If you remember, when you are going to react a Grignard reagent with methanol, then you will be getting primary alcohol. Other than methanol, then you will be getting secondary alcohol. But if you are going to react Grignard followed by hydrolysis in both cases with ketone, then you will be getting tertiary alcohol. Do you remember?
Yeah.
No. So this is the same part. That's why I'm skipping it. Now the next is next B part is addition of alcohols. Addition of alcohols. And it is quite easy to understand. If you are going to add alcohol to this aldehyde, this is your alcohol R-OH, which will be reacting in the presence of HCl gas, hydrochloric gas. So what will happen? It's very easy to understand. There will be formation of this hemiacetal. There will be formation of hemiacetal. First, you are going to write it with me, and then I will explain. Hemiacetal, and then again, if you are going to react it with R-OH in the presence of H plus, then it will be giving you acetal. That is OR dash, and that is OR dash plus H. H2 will be eliminated. Let me know when you are done with this. Let me know when you are done with this.
Yes, sir. Done.
Very good. So have you understood how the reaction took place? It's very easy. So this is your RCH double bond O, right? And you are going to react this with R dash OH. So you also know that this will be, there will be negative and there will be positive charge, right? Yes or no?
Yes.
Mm. And there will be positive and there will be negative charge, right? So can I write this? This positive will go to this negative will go to this positive. So I can write RCH. With O, it is R and R dash, and with C, it is OH. Yes or no?
Yeah.
Yes or no? Again, if you are going to again react this with R dash OH, you know that this will have negative, this will have positive sign. And see, if you are going to react with this, you can either take positive here, negative here, positive here, negative here. If you are going to do this, okay, then this positive will go to this negative, and again same product you will get O, with O you will get R dash. Yes or no? Are you getting my point?
Yeah.
Firaz, see, this positive will go to this negative, and H plus and OH minus combine to eliminate. So this will be over dash and this will be again over dash, and H2O will be eliminated. If you will be going to replace this with this, this again reactant will be as a product. Okay, that's why we change this. And this is your hemiacetal and this is your acetal. This is your acetal. So this reaction of addition of alcohols we only did to aldehyde. Now we are going to do for ketone as well. Okay.
Yes.
Can I change the slide?
Yeah.
Okay. Now see, we are going to do this for ketone, and you know this is your ketone, R and R, which we are going to react with ethylene glycol, which is CH2, CH2OH. Basically ethane 1,2 diol. And again, you are going to react this in the presence of HCl gas, and there should be dilute HCl, dilute HCl. You know what will happen? This will be basically as it is RC, RC, and here O and then CH2, and again O and CH2 will form, which is known as ketal, ethylene glycol ketal, ethylene glycol ketal plus H2. See what will happen here. It's very easy to understand. H2O will be eliminated. First of all, this will be like this, so there will be electron deficient, and here you can see there will be negative charge, there will be positive charge, and this negative will be directly attacking here, and this hydrogen will be eliminated from here. You can see basically what you need to do, just remove this H2O, and there will be positive charge that will be directly attacking here, and this positive will be connected with here, so it will be like this. Got it? H2 will be eliminated. If you still don't get it, just let me know. I will explain it step by step. Should I explain with a step by step?
No, sir. It's okay.
Okay, please do write it.
Done, sir.
Very good. Now the last is basically addition of ammonia and its derivative. Where is it? Where is the easy it is also ammonia and its derivative. So as you can see, this is your aldehyde or ketone. This is your either ammonia and its derivative, one of the hydrogen replaced by Z. Z can be anything. I will give examples of Z. So what will happen? Again, same concept. This will go like this. So there will be positive, there will be negative, there will be negative, there will be positive like this. Wait a minute. Let me show you again. See. This is basically H, and I can write here H. So there will be positive and there will be negative on nitrogen. And this is what you will get. This positive will go to this negative and you will get OH. And here you will get NHZ. And this part is as it is. After this, you are going to remove H2O. That means there this OH and this H will combine to form H2 and it will be eliminated. Now you can see carbon has only 3 bonds, so it will make multiple or double bond with nitrogen in this way. And here Z is basically Z can be alkyl, aryl, hydroxide, NH2, aniline, NHCONH, etc. It can be anything. Please do write. Let me know when you are done with this.
Done.
Very good. So here our electrophilic nucleophilic addition reaction is completed. Now the next reaction is basically about reduction. And one of the reaction we already studied in the previous chapter. So write a reduction. The first one was nucleophilic addition reaction. Now we are going to talk about this reduction. And as you know, in the reduction, we are going to see the reduction to alcohols. Reduction to alcohols. If you are going, we have already studied if you have mild reducing agent or a strong reducing agent. Mild reducing agent, and if you are going to use in aldehyde, it will give you primary alcohol, aldehyde reduction. Then you will get primary alcohol, that means 1-degree alcohol. If you are going to have ketone and you are going to use mild reducing agent, again the reduction, then you will be getting 2-degree alcohol. Is that clear?
Yeah.
Now, reduction to hydrocarbons. The second one is the reduction to hydrocarbons. This is quite important and it's a named reaction, Wolff-Kishner reduction and Clemmensen reduction. That means basically if you are having an aldehyde or ketone, it will be directly converted or reduced to hydrocarbon. So basically, I'm going to write the reaction. If you are having an carbonyl group and you are going to use this ZnHg, zinc amalgam, in the presence of HCl. So what will happen? As you can see, one of the bond will be broken, hydrogen will be added, reduction taking place. Another bond will also be broken or cleaved, and in this manner, and this is what you will get. You will get CH2 and 2H and O combined to form H2O. And this is basically a name reaction, which is Clemmensen reduction. Clemmensen reduction. Now see, if you have C double bond O like this, and if you are going to use hydrogen like NH2 is a hydrogen, then first of all, there will be elimination of water. I will explain the reaction first, write it. If you will eliminate the reaction, H2O, you will be getting C double bond N, NH2. And again, if you are going to use KOH, that means base in the presence of ethylene glycol, and heat it, then you will be getting CH2 and N2 will be evolved. And this reaction is basically known as Wolff-Kishner reduction. Wolff-Kishner reduction. So first write it, then I will explain this.
Nelson.
Very good. So see this, how this reaction took place. Have you understood the last reaction? See, this is your C double bond O and this is your hydrogen. This is what? Hydrogen. So I'm going to write it NH2 in this way. And what I'm going to do, it's very simple. Just remove this H2. I'm going to remove this H2. So what will happen? You can see there will be C double bond N and H2. And here it will be broken. Hydrogen, hydrogen will be added. Hydrogen, hydrogen will be added. And you can see the main product is CH. Now N and will combine to form N2 and the rest part it goes. Got it?
Yeah.
Can you change the slide? Now see, the next third chemical reaction is oxidation. It is oxidation. Let's see what is oxidation. You know, if you are going to oxidize aldehyde, it will be converted into carboxylic acid easily. But when you are going to oxidize ketone, it will not be easily oxidized. So we will be in need of drastic condition like elevated or very high temperature. Then there will be cleavage of bond will take place. The bond will be broken and we will get mixture of carboxylic acid which has lesser number of carbon because the parent chain broken. So you can see this is your RCHO, and if you are going to oxidize it, it will be directly converted into carboxylic acid. But when you are having RCH2, C double bond O, and then CH2 hard acid, then oxidizing with high temperature. The temperature should be high. Now see what will happen. You are going to count the carbon from here 1, 2, 3 because you are going to break it. So if you are going to break the carbon, I'm going to write it here by cleavage of C1C2 bond. C1C2 bond, and every part will be oxidized. So you can see R and C is left here. If you are going to break this bond, R and C, so on the left hand side, this will be oxidized into directly RC double OH. And on the right hand side, this is your R dash, then there was CH2, then there was C double bond O that will be directly oxidized into carboxylic acid. Now, by cleavage of, we will get 4 products. By cleavage of C2C3 bond, C2C3 bond. So if you are going to break this bond, so you can see on the right hand side, it is R dash CH2 left. This will be one. So R dash C double OH, third product, and from the right hand side, left hand side, it is RCH2 C double OH. So whenever you are going to oxidize ketone, it will be oxidized only at elevated temperature with a very strong oxidizing agent. But the condition is that there will be cleavage of bonds, okay, and every part will be oxidized to carboxylic acid. Please do write down. Let me know when you're done with this. Are you done with this?
Yeah, done. Sir.
Wait a minute. So this is how we do oxidation. Now, from oxidation, there are some more important point with which we can easily distinguish between ketone and aldehyde. And here it comes. Tolerance test. Tolerance test. Basically, we use ammonical silver nitrate in this tolerance test. So write with me. On warming, an aldehyde with ammonical silver nitrate. Silver nitrate solution, ammonical silver nitrate solution, which is tolerance reagent, which is tolerance reagent. A bright silver mirror is produced. Bright silver mirror is produced. Now see what happens. Bright silver mirror is produced due to formation of silver metal. Here silver reduced itself, that means it is an oxidizing agent. That means it oxidizes the aldehyde into carboxylate anion, silver metal. And here the aldehyde oxidized aldehyde oxidized to corresponding carboxylate anion. So it's very easy to understand. As you can see, if you are going to use this aldehyde with ammonical silver nitrate, this is your ammonical silver. So you can, this is a complex compound you can write. In the presence of this, the reactions would be basic. So what will happen? This has a oxidation state of plus. This has an oxidation state of +1 here, because here there is a plus sign. So oxidation state +1, and this RCHO will be oxidized into carboxylate anion, and this AZ, you can see oxidation state now 0, so it is reduced along with formation of H2 and 2NH, 4NH3. So basically this tolerance test is because of this tolerance reagent, ammonical silver nitrate. Ketones does not give the ketones is not oxidized by this method. So how we can distinguish between this?
This is a mild oxidizing agent, right? That's
Yeah, it is. It is. Yes, yes.
done.
Okay. The next is basically similar, which is phalanx test. Phalanx test, and there is two containers. We can write phalanx A and phalanx B. First of all, in phalanx A, it is copper sulfate, aqueous copper sulfate, and you know copper sulfate react with water to form water of crystallization 5H2O, which is blue in color, which is blue vitriol, known as blue vitriol. Sorry, I don't remember the color. It is known as blue vitriol. In the phalanx B, the second container, it is basically Rossel salt. Rossel salt. And Rossel salt has a chemical name, which is sodium potassium tartrate. Sodium potassium tartrate. First, you are going to mix it in equal proportion with aldehyde, then that aldehyde will be again oxidized into carboxylate anion. So as you can see, this is your RCHO, and you can see this Cu is in +2 oxidation state. And again, this will be carried out in alkaline medium, basic medium. So this will be basically RCOO negative plus Cu2O plus 3H2O. Now you can see it has +1 oxide, it reduces, that means it is an oxidizing agent. Also, it is very important to note that it is also a mild oxidizing agent, and aromatic aldehydes, not all aldehydes can give this test. Aromatic aldehydes do not respond, do not respond to this test. So we can also distinguish between aromatic and non-aromatic. So please do write it. Let me know when you are done with it.
Done.
Very good. The third and the last is oxidation of methyl ketone by haloform reaction. So see, you know that what is ketone, and with this ketone, if you have a CH3 adjacent to this group, that is called methyl ketone, and this reaction only occur with that type of ketone. Like take an example, RC double bond O, CH3. So first you are going to react this with sodium hypohalite. This is known as sodium hypohalite. So what will happen? This will be replaced by ONA, this part. So it will be converted into RC double bond O, ONA, and haloform will form CHX3. And this reaction is only for chlorine, bromine, and iodine, not for fluorine. Are you getting my point? If I'm going to take an example, Firaz, so this is the example that I'm going to take. And if I'm going to react this with NaOCl, what will be its name? Its name will be sodium hypochlorite. So what will happen? Just focus here, and adjacent to this is this and this. So this part will be replaced with ONA. This part will be replaced with ONA. And the next is CHCl3, which is chloroform. Is that clear? So if there will be any question like which one will show haloform test, so you need to find a ketone which has CH3 group attached to adjacent of C double bond O group. Got it? Firaz?
So can you tell again?
I just told you that haloform test will show only when the compound will have CH3 group attached adjacent to this C double bond O group. Are you getting my point? Should I repeat it again? You can see this is the ketone, and if a CH3, not anything else, but exact CH3 is attached adjacent to this ketone group, that will only show the haloform reaction or haloform test. And that is known as basically methyl ketone. Got it?
Yeah. Okay.
Please do write it.
So it responds, like, how do we know it responds?
How do we know?
It responds to the reaction.
When you do reaction, if the product will form, then it is methyl ketone. That means the ketone which you are reacting is having a methyl group which is adjacent to C double bond O. Are you getting my point now?
No, like in other reactions, we saw silver mirror. Like that, do we see color here?
If you have this type of group and you are going to react this, the reaction will not occur because it doesn't have CH3 group. It is not methyl ketone. If you are going to react this with sodium hypohalite, then reaction will occur because here is what?